Welcome to the solutions video for assignment 3.05 number 3. So we are looking at algae growth on small lakes and ponds in southern Manitoba. We've got the number of weeks. We've got the percentage covered by algae. We need to find by what percent are the algae growing every week. And assuming the same growth, how many weeks will it take for the algae to cover 80% of the pond? So for this, we will go back to our spreadsheet. I've got the data entered already. We will insert a chart and we will make it a scatter as usual. And we are going to be looking at a trend line that is exponential. We label our equation, and there we have E exponent 0.0954. So if we turn that into a base, if you're using the TI calculator, it should be similar to this. This 1.10 says after each week we're at 110% of what we had the week before. Therefore, our growth rate is 10%. And we need to figure out how long it'll take before we hit the 80% mark. Well, for that, we'll need to make sure our chart goes up to the 100% mark so we can change our maximum. We go to our horizontal axis and we can change the maximum there. And it looks like we're somewhere in this region. It's about the 10 or 12 week region. We could also simply graph it. And as we can see, I haven't cleared the graph since the previous homework assignment. So let us just start a blank new graph. So we are at 25 times e to the 0.0954x. So 25 e 0.0954x. So that's what y equals. We want to make sure our y-axis goes up to 100 to catch all the percents. And we hit the 80% mark in a little over 12 weeks. So 12 weeks won't do it, 13 will. At least with this model. If you're looking at the model from your calculator, you are more likely to have this one. Still about 12.2 weeks. Rounds just ever so slightly differently. So that is question 17, or question 14. Question 17 is at the top of the next page. So the light intensity of a spotlight can be reduced using gels, which are placed in front of the light. The table to the right represents the intensity of the spotlight after a given number of gels have been used. Explain how you could create an algebraic model of the data. Well, with this, we could say that we are at 100 minus the percent drop for each gel, which looks like it's about 3. Determine the light intensity of a spotlight if 7 gels are used to 2 decimal places, and the minimum number of gels it takes to get down to less than 40%. So again, we will come here. So the number of gels used, you see that is tapering off here, but very, very slowly. So we do want to add our exponential trend line. We want to use the equation. Our vertical axis is fine. That goes from 0 to 100. Let's go at first 20 for the max. That's not going to do it. Let's go 50. 50 will get us to the 40% mark. So at this point, we seem to be losing 3% per gel. So if we have 7 gels used in this case, this equation says we're going to have 100 times exp negative 0.0305 times 7 gels used. So that's going to get us down to about 81% of the intensity. If we want 40%, then we can do it algebraically, and the natural log of 0.40 divided by negative 0.0305 gives us about 30. So it's about the 30 gel mark where we hit our 40% intensity. And remember, for the algebraic version, we're going to have the original amount first times 1 minus the percent loss. In this case, it looks like about 3 over 100. And the exponent will be the number of gels used. That will just confuse our spreadsheet, so we'll get rid of that. But that finishes homework solution 3.05, number 3.